This is A-level Computer Science 9600. This is paper 3 and this is chapter 5 security. Okay, so let's begin. We're going to cover this chapter security in one video. So let's get started. First of all, let's discuss about what are public keys, private keys, and what are plain text, ciphertext, encryption, decryption, digital signature, digital certificates, quantum cryptography, and etc. Let's start from here. Public key and private keys. So public key is an encryption. We can use it for encryption, or we can also use it for decryption as well. Known to all users, which means something which is public. Something which is public. Everyone knows. A key, a key can be used for encryption, and as well as for decryption as well. But depends whether it should be known to the user or it should be kept to the user. Okay, so that's the difference between public and private. Public key, known to all users, encryption, decryption. Private key, also encryption, decryption, which is known only to a single user computer. Okay, plain text is the original text. Ciphertext is when you have encrypted the text. That text is the text is posed through an encryption algorithm, so it's completely encrypted. Okay, so then you can call it a ciphertext. Encryption alter data into a form that is unreadable by anybody for whom the data is not intended. For eardroppers, hackers or third party, which are not for them to, they shouldn't be allowed. Okay, its encryption is just to increase the security when you are sending some personal information. Let's for example, you are accessing your bank account on a website, so you are sending your personal PIN, your email address, your username, and the bank will try its level best to encrypt those valuable data. Okay, so that's encryption, my friend. Symmetric key cryptography, encryption in which the same secret key is used to encrypt and decrypt the message. Symmetric key is it's popular, but it's not really recommended because it poses a security risk. For example, that same secret key could be get in the hands of the eardroppers, or in the hand of the hacker, and that third party could use that key to decrypt the message. So it's a security risk here, since the sender has to supply the key to the recipient. This key could be intercepted. This is referred to as the key distribution problem. Okay, so you got Alice and Bob. They are playing catch. Yes, Alice is sending the key. It comes to the here, and okay, so Alice first of all encrypt the message, send the message, and it sends the first of all it encrypts the message. Okay, it sends the key, the message encrypted also been sent, and then using that key to decrypt the message. Okay, that's how it is. Okay, asymmetric key in cryptography is very recommended, much better than symmetric, because asymmetric contains the public and private key. It contains these two beautiful keys to encrypt and decrypt the message. Okay, uses public key and private key to encrypt and decrypt the message, the plain text. Okay, so how does it work? This is a scenario where you are sending a private message to an individual organization. It could be used for individual organization, it could be used between two people as well. So each receiver and sender has a public private key. Mira sends her public key to encrypt the message. Okay, so she sends the public key. She sends from here. She sends the public key. This is a public key to encrypt the message. So this is the sender, this is the receiver. Okay, so sending the public key, it comes here. The sender, the Tom, will try to use that key to encrypt the message. Okay, and that message will be sent to Mira. The encrypted message sent and then Mira decrypted with her private key. So private and public key being used. Public key is being sent to Tom to encrypt that message. The message is sent to Mira and then Mira will decrypt it through her private key. This is encryption. This is asymmetric encryption. Very popular. Okay. Then we came. We are now will take on account. We'll see that this security concerns that why. I mean, if we want to, for example, we have the data. Okay, we want to secure that data. So, what are those security concerns that we need to look into in order to make sure that our message is secure, confidential, uh, um, authenticated, integrated? I mean, it has not been altered in some manner. Okay, not altered or changed during transmission, and also that receiver and sender could be verified. Okay, so these are the security concerns. Confidentiality means only the intended recipient should be able to decrypt the ciphertext. Okay, only the intended ones. This one is confidential. Authenticity, the receiver must be certain who sent the ciphertext. The receiver must be certain. Integrity, the ciphertext must not be modified, must not be changed during transmission. And non-repudiation, sender receiver not in denial for the involvement of the transmission. This is so simple. Obviously they should not be in denial, and they should be aware of what they are doing. Availability, nothing should happen to prevent the receiver from receiving the transmission. Nothing should happen to prevent the receiver from receiving the transmission. Nothing should prevent that. Nothing should be difficult for the receiver to receive the transmission. Okay. Digital signatures can be used to make sure that it does not be modified in some manner, and also that the receiver must be certain who sent the ciphertext. Yes, it can be used in some manner, but this too is not so much successful because it still does pose a security risk. We will discuss this later. Okay, we will discuss this later. Okay, now, okay, send a verified message to the public. Sending a verified message to the public. Yeah, you can use digital signature and digital certificate. Okay, quantum cryptography is a very expensive but also a very effective one, where the military and government use this. Okay, so very high technology, high stuff, the quantum stuff. We use this quantum cryptography using quantum mechanics properties, and using those properties we can make sure that yes, this thing is a bomb. Okay, it's very effective, and even if eardroppers or hackers in any way try to access the message, it would still be encrypted and they cannot possibly decrypt the message. Okay, so what is quantum cryptography? Utilizes the physics of protons. We are using physics here, my friend, not maths. That's the difference. We are using physics. Asymmetric encryption and symmetric encryption, we use mathematical formulas to encrypt the messages. Okay, using mathematical formulas to encrypt the messages and to create private key, public key using mathematical formulas, logics, numbers. But in quantum cryptography we are using the physics. So it utilizes the physics of photons and their physical quantum properties to produce a virtually unbreakable encryption system. Okay, it is virtually and it is unbreakable, and it is also encrypted. It's related to quantum mechanics. The particles that transmit light are called photons. Photons, we have discussed. We have already we know about photons, right? They are light particles in physics. Photon demonstrate wave behavior so that each photons appear to vibrate in a particular direction at right angle. It can it is vibrating. Each photon can vibrate in any particular direction. Okay, we don't know anything about it. I mean, it vibrates so many random direction. The direction each photon vibrate in is called is called its polarization. A photon can be created with a specific polarization to represent a value. Okay, we can create a photon with a specific polarization. Either it could vibrate horizontal, vertical, diagonal, in this way or in this way. Okay, a photon can be created with a specific polarization to represent a value, 0 and 1 bits. Okay, each specific polarization represent a bit value. Okay, represent a value. Like here we are polarizing it. Now it's going to vibrate vertical. It will vibrate in this manner. We polarize it, it will vibrate in this manner. We polarize it, it will vibrate in this manner. 0 bit, 1 bit, 45 right polarization, 1 bit, and 45 left polarization, 0 bit. Okay, so we are polarizing it and they are vibrate in a specific direction, and we can just use this knowledge, and we can just convert this. We can make sure that it represent a value. Okay, to represent a value for a bit, this enabled to create shared secret code consisting of number of bits. Okay, so that's how we use quantum cryptography. We are using the vibrations. So, okay, qubit is the unit name. You use the qubit as a basis unit of quantum data. The state of a qubit can be 0 or 1, but it can also be with 0 and 1 simultaneously. Okay, it can be 0 1, or but it can also be 0 and 1 simultaneously. Okay, it could change, I guess. QKD, sending encryption keys across a network uses OKD protocol. Okay, so it's a protocol. Quantum key distribution, we also have this key stuff. So what does this OKD protocol tell us? How do we use the keys like we have used this in asymmetric encryption? Okay, how do we use the keys? Yeah. Okay, the sender chooses the bit pattern at random and all. Okay, so it's choosing the bit pattern at randomly, and also the polarization. Okay, choosing the bit pattern at randomly, and also choosing the polarization basis for each value, whether it should vibrate vertical or horizontal, in this way or in this way. Choosing the polarization for each value at randomly. Okay, the receiver chooses a polarization basis for value at random. Okay, so what's happening here? Let's start from here. Alice wished to send a Bob a message. Alice initiate the message, sending Bob a key or a stream of photons. Okay, so photon first pass through a polarizer like this one. This polarizer, this is a polarizer. It pass through a polarizer, uh, polarizing each photon in a certain state as Bob receives the photon. Okay, so Alice has created, these number of photon, and they are vibrating in a specific direction, and they are representing the bit of value, a value bit, and it Alice has sent this message. Okay, Bob received these photons, but Bob doesn't know the correct polarization, so it randomly used one of the two beam splitter. Beam splitter means this is a beam splitter, or this. Okay, so these two beam splitter to read each photon's polarization and decipher the key. Both sender and receiver compare the splitter they use. Okay, now they will at the end, what did Bob did? It tried to generate the, you know like, try to generate after receiving the photon, generating it like, having bits, and you're generating it using beam splitter. Okay, randomly use one of the two beam splitter to read each photon's polarization and decipher the key. Both sender and receiver compare the splitter they use. The photon read with the wrong splitter are discarded, and the remaining sequence is the key. Okay, so this is how it works. At the end, we already try to compare the splitter which is the common splitter that both the receiver and the sender have used for that particular bit. Okay, and any other wrong splitter are any other wrong splitter that are used for that photon are discarded. Okay, Okay, so the receiver chooses a polarization basis for value at random, like I've discussed in here. The sender informs the receiver about the polarization basis used for each value. Okay, the sender informs. At the end, they are comparing it. Okay, both the sender and the receiver about the polarization basis used for each value. For these matches, there is now a stored value for a bit. Okay, like in here, this is the sender have sent this message. The receiver has created this, and now there's a comparison. Both split the same. Okay, come out, come out, come out, come out, and there you go, you got this number of bits. Okay, yeah, okay. Plus means that vertical horizontal vibration, and multiply symbol means that you're vibrating this way and in this way in diagonal. Okay, what are the disadvantage and advantage? Anyone trying to intercept the flow of photons in an attempt to discover their polarization will by the law of quantum mechanics destroy the photons, not protons, sorry, photons. Let me write it out. Photons. Photons. Disadvantages: it cannot be implemented using standard communication media. It requires a dedicated special purpose quantum channel between sender and receiver, which means you need a fiber optic cable to use this, and fiber optic cable is very expensive. Cost of providing it is very high. Possible for the polarization of the light to be altered. Yes, this is also the weak point here, because there's a risk. There is a risk factor that the message could be changed. It could be filled with errors, because the polarization of the light can be altered. Okay, so this is the quantum cryptography. Yes, we are done with this. Now we are moving ahead to digital certificate, digital signature. What is digital signature? For example, you have a document, you have very important documents, and you just decided to put a signature on it, just to give the just to relieve the receiver that yes, these are my documents and I am the one who signed it, so it is verified that this came to a valid source, valid sender. Okay, this is what signature means, right? But in digital form, we are trying to validate it come from a known user, and also need to make sure that the message has not been altered in some manner. So validating the authenticity of the digital document. What is authenticity? We discussed. It means that the receiver must be certain that who sent the ciphertext. Okay, who sent it, like I told you. So validating the authenticity of the documents, and also proof that a document was sent by a known user. The plain text is put through a hashing algorithm which produces the digest. Okay. The plain text is put through a hashing algorithm, and which produces a digest, a small mathematical calculated value. The sender's private key is used to encrypt the digest, known as digital signature. So this is a digital signature. So what we have done, the plain text go through hashing algorithm, you get a digest, the sender will use a private key to encrypt that digest, and it will be known as a digital signature. Okay, the message can be transmitted as plain text together with the encrypted digest as a separate file. You can call it the digital signature. Okay, so transmitting the plain text, also the digital signature as a separate file. The recipient put the digital signature through a decryption algorithm using the sender's public key to get the digest, and then we try to compare it, and if the receiver then puts the plain text. Okay, so after receiving the message, for example, the sender and the receiver, what the sender did, it first of all it put the plain text into a hashing algorithm, you get the digest, and then sending the plain text and the digest as well. You're sending the plain text and the digest as well to the receiver. The receiver will use the sender's public key to decrypt that encrypted digest. Okay, the digital signature. It will use the sender's public key to decrypt the digital signature to get the digest. Also, it will, after getting that message, the message will again put through a hashing algorithm to calculate the digest, and then both the digests are compared. The receiver then put the plain text through a same hashing algorithm and also produce the digest. If these two digests are same, then the document has been sent correctly. If it needed to be kept confidential, then it would be necessary to put through asymmetric encryption. Okay, confidential means what is confidential? Confidential means that only the intended recipient should be able to decrypt the ciphertext. Not any third party should come, but only the intended recipient. Confidential. So in order to have confidential, we use asymmetric encryption. Okay. This method is still not safe enough since the public key could be forged by a third party, which means the recipient still cannot be certain that the message came from a legitimate source, whether the message came from a sender or from a third party or from a hacker. Who knows? God knows best. Okay, so now we come to the digital certificate. Digital certificate used. What is a digital certificate? Okay, so it is used to produce digital signatures. It's a part of the process in a digital certificate. One thing for sure, digital certificate is used to identify the sender. The problem that was occurring when we are using digital signature, that who the sender was, either it could be a third party or it could be someone else or it could be my friend, who was the sender. So digital certificate is used to identify the sender, giving you the certificate of being a valid sender. Electronic document used to prove the ownership of a public key. It is to prove that the data is from a trusted source. More rigorous means of ensuring authentication. This can be provided by CA certification authority. Okay, so it proves the ownership of a public key. Number one, prove that the data is from a trusted source. Okay, same thing. Number one, I guess. Number two is ensuring authentication. What is authentication? I'm completely forgetting all the time. Authentication means it come from a valid source, I guess. Come from a valid source. Yeah, who sent the cipher, I guess. It comes from a valid source. Okay. Most common use of a digital certification is to verify that a user sending a message is who he she claims to be. It's the same meaning, I guess. I don't need to write down. Ensuring authentication is the word. The person A which have a public private key pair the person A. So we got person A, person B. This is A, this is B. Okay. The person A which have a public private key contacts a local CA. So now it contacts to the CA. The CA confirms the identity of the person A. The person A's public key is given to the public key is given to the CA. The CA creates a public key certificate, which is known as a digital certificate. It creates a digital certificate and writes a person's public key into the digital certificate, into this document. The CA uses encryption with the CA's private key. Okay, now the CA has its own private key. The private key, I guess, key. The CA creates a public key certificate. Okay, and writes. Okay, the CA creates a public key certificate, which is known as digital certificate, and writes person A's public key into this document, and then the CA use encryption with the CA's private key to add a digital signature into this document. Okay, now using the CA's private key to add a digital signature. Digital signature. CA use the public key to create a digital certificate, and using the sender's public key, you're writing the sender's public key into the document. Then using the private key, the CA's private key, to create a digital certificate, to add a digital certificate to this document. This is to confirm that the certificate came from the CA. This digital certificate is the person's is public key. Okay. Yeah. After giving it to person A's message is put through a hashing algorithm. After giving it to person A, now you return this to person A. The person A's message is put through a hashing algorithm in creating a digest hash total. Hash total is encrypted with person A's private key digital signature. Okay, so there are two digital signatures. One digital signature is to confirm that it came from the that should not be altered in some manner, I guess, and also to confirm that the certificate came from the CA. Okay, digital signature for the CA, and another digital signature for the message by person A. Hash total is encrypted with person A's private key digital certificate digital signature. Okay, person is send message and encrypted hash in digital signature. Person A posts the digital certificate on a website. Okay, the CA makes it on public key readily available through the internet. Only the CA's public key will allow decryption of the certificate, proving the certificate was issued by a CA. Okay, so person A posts the digital certificate, the CA makes it on public key readily available through the internet in order so that it could use it to decrypt the digital certificate. Any other person wishing to use a person A's public key download the signed digital certificate and use CA's public key to extract person A's public key from the digital certificate. Okay, using the CA's public key to extract the person A's public key, okay, from the digital certificate. That's why we need the CA's public key. So we use the CA's public key to decrypt to extract the person's A's public key. Okay, this is what I have written here. Only the CA's public. Okay, and also another thing is the CA's public key will allow the decryption of the certificate, proving the certificate was issued by the CA. Person's A's public key is used to decrypt the received decrypt the digital signature, which will get the digest, and the receiver hash the received message as well, getting another digest. Two digests are compared, then message is authentic and has not been altered. So there you go, complete. Number one, it has not been altered, which means we know the authenticity. It has not been altered in some manner. It is completely fine. And another thing is that you are also giving the confidential authenticity that it comes from a valid source by the digital certificate by the CA. Okay, certification authority. Only the CA's public key will allow decryption of the certificate, proving that the certificate was issued by the CA, certification authority. Okay, so yeah, this is why we use digital certificate. Okay, it's done. Now the last thing we have to come is SSL and TLS. These are protocols when we are, these are protocols like for example protocol used in the website to make the website more secure and to make it secure against hacker and eardroppers. Okay, so it ensures security when using the internet. For example, you are accessing your bank's website, and you need to make sure that whatever you try to give the information is completely encrypted and secure. So in order to make sure that it happens, we use these protocols, SSL and TLS. SSL is socket. I don't know what this is, but SSL means that, well, it's a protocol. TLS is an extended version of SSL. Okay, TLS is the extended version of SSL. Let's start from SSL, or no. Okay, I have put this box representing that the both of them contain these features. So let's start from here. So it ensures security when using the internet, are both part of the transport layer, ensures secure and authenticated communication between client and a user. When the client is when a user the client is using the websites, the bank website, you know and doing transaction, etc. It encrypts the data. So these are the common features of both in both of them. SSL specifically used for, it can do data compression, data integrity checks, HTTPS. Whenever we try to see HTTP and we have this beautiful S right here, then it will be confirmed that yeah, we are using the SSL protocol. Okay, and we have also get the lock sign, something like that. The web server needs to obtain the digital certificate to allow SSL protocol to be used. Okay, so we use, so it's a so whenever we use a digital certificate, we get the SSL protocol. And I think it's the SSL is so popular that even Google has decided to make sure that all websites need to use SSL protocol. TLS is a very extended version and used by organizations, and we also need to purchase the something like that, purchase something. Okay, there could be a membership of something, purchasing a certificate or some form. TLS is very extended version of much more advanced than SSL. Okay, that's what I'm talking. So using SSL, we can do online banking and all online financial transaction. I mean, it used in that. Sending software to a restricted list of users, we need the SSL. Okay, sending and receiving email using VPNs and etc. What does TLS do? It is a modern, more secure version of SSL, form of two main layers: record protocol, handshake protocol. Record protocol is when it deals with the format of data for data transmission. Handshake protocol permit the web server and the client to authenticate each other and to make use of encryption algorithms to authenticate each other. You are doing a handshake. Okay, so this handshake protocol. Possible to extend TLS by adding new authentication methods. So that's another advantage of TLS, that you can also add extraordinary things, new authentication methods into it. We can make use of session caching. What is session caching? Allow the previous computer session to be remembered. Like for example, you have this website, you have this particular website. Okay, you got this button. So when you click and then you just want to go back as well though, so that data is stored in the cache, and that cache is used to make sure the computer remembers it, and it also helps us to go back without loading too long. So that's why that's where we use session caching. Preventing the need to establish a new link each time a new session is attempted, which means if you are going forward so many times and then we decide to go backward, then it will go so fast. Okay, so it will go so fast because that data is stored in the cache, and that cache is helping the computer to remember that session, like that session that has been previously been formed. Okay, you know the idea, you get the idea, hopefully. Or you can ask me, can make use of session caching which to improve the overall performance of the communication. So session caching comes in TLS. The client's web browser requires the secure pages from, okay, this is a sequence that how does it work, how does handshaking or protocol take place, how does it work. The client browser requests a secure pages from a web server. We got the client browser, we got the web server. Step 2, web server send back SSL digital certificate plus its public key. The web server, you got the client, you got the web server. The web server sends its digital certificate and also its public key to the client browser. The client browser receives it, checks digital signature of CA, that the digital signature of CA, that just to confirm that it came from the C. C and checks the digital signature of C, and we know why we use to authenticate that it came from trusted source at some point, and it has not been altered. Once the browser trusts the digital certificate, the public key, which form part of the DC, is used to generate temporary session key with the web server. Okay, we use the C as public key. Web server uses its private key to decrypt the session key. So the browser is using the public key to generate temporary session key with the web server. The web server uses its private key to decrypt the session key and then sends back an acknowledgement that is encrypted using same session key. The browser and web server can now encrypt all the data sent over the connection using this session key. A secure communication can now take place. So this is how it works. Okay, so yeah, so or maybe let me just summarize this. So we got the client and the web server. The client requests some pages, the web server gives the digital certificate, the client will receive it, checks it. The client trusts the digital certificate using the public key to generate a session key. Web server uses its private key to decrypt the session key and sends when an acknowledgement that is encrypted using same session key. The browser web server can now encrypt. That's it. Simple. The browser and web server can now encrypt all data traffic sent over the connection using this session key. Secure communication can now take place. So this is the end of this chapter. Thank you so much for watching, and I'll see you guys in another topic, which is another chapter, which is AI, artificial intelligence. A very interesting, very important topic. I think it's one of my favorite, and I will show you guys is that I will we will discuss this in the next video. Thank you so much for watching.